Okay, we are moving on. We are still using our unit circle, but we are talking day 15 about reciprocal identities on our unit circle. The notes will be published for you to follow along with those as well if you'd like to, and we will be continuing with this on Monday as well. Okay, so as a review, we're going to solve. And when I'm looking at this, I have 3 secant theta sine theta minus 2 square roots of 3 sine theta. So these both have a sine in common. So I'm going to factor out a sine theta, and I'm left with 3 secant theta minus 2 square roots of 3. We get nervous about this, but remember this is just a number. Okay, so 2 square roots of 3, totally fine leaving it like that. Okay, equals 0. And then I set each piece equal to 0 and solve. So I have sine theta equals 0 and 3 secant theta minus 2 square roots of 3 equals 0. Where is sine 0? You'll find that on your unit circle. So theta equals 0 and pi. Remember, I'm saying go up to, but don't include 2 pi, so that's why I'm not adding 2 pi to my answer. Here's where things get a little trickier. I'm going to add 2 square roots of 3 to both sides. Divide both sides by 3. I forgot my theta symbol. So I have secant theta equals 2 square roots 3 over 3. Remember that secant is the reciprocal of cosine. So I'm going to flip it and say cosine theta is, let's see, square root 3 over 2. You guys can look on the back of your unit circle to find that. The 2 places I get for theta then are pi over 6 and 11 pi over 6. So this one has 4 answers. And you can find those all on your unit circle, which I'm sure that you have out and handy. And if you don't, you should get it out now, okay? Because we are going to use it. Remember, when we watch videos, we can pause misvote at any time, which is nice. So if I'm talking too fast, make sure that you just stop and pause and take notes at your own pace. This one says right here, there's no need to write this down, but an identity is an expression that holds true for all values of variables. So like this one, we call the difference of perfect squares. Like if I have x squared minus 36, I know it factors into x minus 6, x plus 6. That's what this is getting at. You may or may not have last year talked about the difference of cubes. An example here would be like this. And you would factor into x minus 3, x squared plus 3x minus 9. Okay, so it would look like that is how you would factor it. But we're going to use these identities or the idea of identities as we move forward. So there are the most common reciprocal identities that holds true for everything. You are maybe going to want to block off, I don't know, half a page in your notebook, maybe put a post-it note there or fold the corner over, because we're going to focus a lot on these identities right now and for the next few days. Okay, so the most these are the most common. I could also write these as their own reciprocals, like sine theta is technically 1 over cosecant theta. Cosine theta is technically 1 over secant theta. And tan theta is 1 over cotan theta. So these have, they're also reciprocals of each other. What we're going to do is use these reciprocals, these reciprocal identities, to make substitutions when we can't go any further with our factoring or anything like that. Okay, so if you don't have these written down, pause, write them down, have them in a spot where you can return to them often. So in our first example, this should look similar to what we've been doing, and you'll look at it and you'll see sine theta times Remember, if they're touching, there's like a dot there. Cotangent theta equals 0. And then you're probably asking yourself, like, what do they have in common? Turns out that sine and cotangent don't have anything in common at all. So what we want to do is make a substitution. And we are going to look and like, what things do we know? All right, let's just try some out. Use a color. I know that sine theta is 1 over cosine, for example, right? So we'll try to substitute for sine theta. 1 over cosecant theta times cotangent theta equals 0. This doesn't really get us anywhere. That's not the substitution that I want. No big deal. Let's try a different one. What else do I know? Oh, I know that cotangent is, I know cotangent, for example, is 1 over tangent. Okay, let's try that. So I'm going to leave sine alone, and cotangent is 1 over tan theta. Still, I don't see anything good that will help me. Not working out. That's okay. The biggest frustration that you guys will find is that you sometimes get it wrong. So here's me getting it wrong twice. How do I know I got it wrong? Because I looked and I saw sine times 1 over tan. Does not help me. I don't know what to do. I'm just as confused. But there's another substitution I can make for cotangent, and it looks like this. So let's try that. Let's try leaving sine theta alone and substituting in what we know, that cotangent theta is also cosine theta over sine theta. And guess what? This is something I can do because look, I have a sine divided by sine. Those turn into 1 or cancel out, as we like to say. And then all I'm left with is cosine theta equals 0. This is something I can find on my unit circle right here. Cosine theta equals 0 at pi over 2 and 3 pi over 2. And those are my answers for this one. Okay, so what happened? Let's just walk through it. Sine times cotangent. I didn't know what to do. So I started just making substitutions, and I thought, what do I know? What can I substitute? I know that sine is 1 over cosecant, gave me nothing. I know that cotangent is 1 over tangent, gave me nothing. But I had a different idea. I used the fact that cotangent is cosine theta over sine theta and made that substitution, and that worked for me. Okay, so these, you might get some false starts. Let's just say that. Okay, and the same way might not, like your friend might do it a different way and get the same answer, and that works too. Okay, so as a teacher, I think these are fun. You guys struggle with these. All right, so I've got secant theta times cotangent theta equals 2. Maybe I'll try the same thing as last time. I know that cotangent is cosine over sine, so I got this. Secant theta times cosine theta over sine theta equals 2. That didn't help me. Let's see. But I do know something. I do recognize that secant is 1 over cosine, so maybe I'll make 2 substitutions. Let's try that. This is 1 over cosine theta. And this is still cosine theta over sine theta. Okay, now we're getting somewhere. Now I see things that can happen because I've got this. So now I've got 1 over sine theta equals 2. You guys might see a couple things here. 1 over sine theta, I can make one more, right? 1 over sine theta is the same as cosecant theta, so where does cosecant theta equal 2? I feel like I'm going back and forth now because cosecant theta equals 2 in the same place that sine theta equals 1/2. Okay? If you want to jump right to here, you can think about doing cross multiplying, right? Like 1 equals 2 sine theta, divide, and you'll get sine theta equals 1/2. That's another way to think about this if you'd like. Again, there are a lot of paths to get to this answer. Where is sine 1/2? Sine is 1/2 at pi over 6 and 5 pi over 6. So those will be my answers here. Okay, if you stumbled, don't be afraid to try a different way. Don't be afraid to erase everything and try again. Okay, it will be okay. Those are the example notes for today. I will make sure everything is published for you so that you can go ahead and do your homework and check all of your answers. You guys can email me or always check with Miss Harrod or Mr. Crowett next door if you would like some help. And then that's it. See you guys Monday.